Hello and welcome to part 7 of the Python for Finance tutorial series, and in this one we're going to focus on events. And when I say events, it can be company specific event, industry related event, or an event such as the COVID-19 that impacts the entire world. In this tutorial we'll focus on COVID-19 as well as the financial crisis of 2008. So what I've done here is I have part of the code already filled in. Actually, what I have is just a list of the indexes that we're going to use. We have a dictionary to translate these keywords that we will need to get the data using Yahoo Finance. So basically, if you go on Yahoo Finance and search for S&P 500, basically this is what you will get back as the keyword that Yahoo Finance needs to recognize the index. So we have a nice distribution of indexes from all over the world. Now the start and end point that we're going to use would be 2019 November 1st until, let's say, 2020. Let's use the latest date that we can. So for me it would be 11 and then 7. So 7th of November. It would be a bit over a year. So what we have now is we have to make sure that we have the correct indexes. If you're working on analyzing a particular event that impacts industry, you want to make sure that you have the correct company selected. But it could be that you have one event that impacts only one company. In that case, you don't need to do exactly this. You won't have to loop through that list. It would be just one index or one ticker. So what we're going to do next is, for every index that we have in indexes, we want to first get the data. Then we want to make sure that our data is converted to pd.data frame of data. So we want to make sure that it's a data frame so we can work much easier with it. We want to calculate the percent change, and then we want to multiply these changes throughout the period to make sure that we have the year-to-date change, and then we can plot that to see how the COVID-19 had impacted all these economies. So first, to get the percentage change, we can just use data adjusted close dot pct underscore change, and then when it comes to creating the year-to-date change, we need to think how are we going to present this at the end, and what are the next steps. So ideally at the end we would have one plot with all these year-to-date changes, drops and also recovery of the markets plotted. But this is actually what we're going to replicate for all the indexes. So ideally we would like to have here the index. So this would be the column. If we have multiple columns, we want to have one column for all of these per index. So let's start with that, and then we'll see how that looks like at the end. Then we want to make sure that we have data percentage plus 1, right? Because we want to multiply that, so we need to have the plus 1 dot cumulative product. And we can leave this for now. So if we run this, we would get the year-to-date return. Actually, it won't be year-to-date. It would be just the return. I was saying that wrong, but it would be just the cumulative return for since 1st of November 2019 until 7th of November 2020. So maybe I'll just select. Let's do it this way. Let's create a total returns data frame, which would be for now an empty data frame. And then we're going to add all these total or cumulative returns, so not year to date, but cumulative returns to that. So if our total returns is empty, so if it's our first time running through this loop, we want to make sure that total returns is equal to data index, which is basically this cumulative product or the performance of the market through that period of time. If that's not the case, then our total returns we would be equal to total underscore returns dot join data index and then how outer. So that's the method of joining. Now, one thing that we need to keep in mind is that these economies, these countries, when it comes to the indexes, it doesn't mean that they were open on the same day. So sometimes there are national holidays and maybe it was not working, the US stock exchange was closed or the Japan one was closed. So what we're going to do is, let's actually just plot what we have at the moment. So let's plot our total returns. And in order to do that, as we said, we want to make sure that we don't have this GSPC or GDAXI. We want to have this like Germany or Japan and so on. So what I'm going to do is, let's first create our subplot to grid. So AX1 would be plt.subplot to grid, which would be 1 by 1, 0, 0, that's the starting point, row span of 1, col span equals 1, title is equal to, say, COVID-19 impact. Now, for every index that we have in our indexes, we want to plot that data on our axis that we created, so on our grid. How do we do that? Well, in our total returns, we already have information about the index, but the label would not be the index itself because, well, that's what we're trying to avoid, and that's why we have this dictionary. Instead, our label would be equal to dictionary of index. So what this for loop does is it takes the total return of that index. So let's say it's GSPC, then it goes to the dictionary and gets the value, so US, and that would be the index. So let's add the legend and show how it looks like at the moment, and as well as what else we need to change to make sure that it looks better than it already is. We can also show the grid if necessary, but all right, so a few things that we can see. We have some missing data, and that's indeed the days when some stock exchanges were not open, but not all. So we need to make sure that this is being handled. So we need to really do that, so it looks better. Then what we need to do is we need to make sure that this is in percentages. That's the second thing. So let's start with that and see how we can continue and what else we need to change. So the easiest way to get to adjust for missing data is if we take our total returns, and basically what that is maybe I'll just comment this part out just to make sure that we understand that. I'm going to get total returns hat. So the first 5 results. How this data frame actually looks is like this. So we don't have anything for the first day because, well, we couldn't divide with the previous one as we didn't have the data. Then, for example, we see that in Japan, one of these days was closed, so we can't calculate it for the second date. But maybe if we have a longer period, so total returns, let's get 25. We should be able, for example, here to see that the US was closed on this day which was not the case for the other indexes. So if we adjust that total returns to be equal to total returns dot drop NA, what it would do is if there's at least one NA in the row, it would drop the entire row. Now, since we have the total returns already, it would not have any impact on our graph and the values, except we won't have those values. And I think in this case, that is a good way to solve it. So I'll add a comment here. So this is basically removing rows with missing values. I think this is a good comment to have if you're reviewing this in a few months or a year. Then the second thing that we need to do is we need to make sure that we have percentages. So for that purpose, what we're going to do is we're going to import matplotlib.ticker as mtick, and then down here, after we've plotted the index values, what we're going to do is ax1 dot y-axis, because well, the y-axis is the one that we want to adjust. You're going to set major formatter mtick dot percent formatter. So now we have the y-axis in percentages, but I think it would not be quite good. It would probably show 1% instead of 100, but we'll see how that looks like. Yeah, so what we need to adjust is this one to be multiplied by 100, so it shows the correct percentage, but for the rest it looks quite okay. The lines that we have are actually, we don't have any missing values, and then we can take a look into, okay, what has happened in these markets that we have. So how do we adjust, or where should we adjust for the percentage? I think this is the best way, and that's when we're calculating the total return. So if we take a look at the total result and this visualization, what we should be able to clearly see is how the economies reacted to it. Now, if you take a look at China, which is this purplish line, the impact there was much earlier compared to the rest of the world, because they were the first to report cases. And even though that had impact in the other parts of the world, it was not that significant. So one thing that we can notice is the impact on the index there much earlier, and then of course it also had impact when it dropped for the entire world. The economies that were most impacted, measured by the indexes, are Germany, France and Spain. So the Europe economies were impacted the most. And then if we take a look at the recovery for the next 7-8 months, basically US and China are both now at even a higher level than they were before the COVID-19. So they've fully recovered, at least the markets measured by the indexes, or the indexes recovered, not the economy. Then Japan is the next one. Then we have Germany, France, and then Spain is actually still not at the level before COVID-19. So the impact, we can say that it was probably this is between 100 and 110%. So, and it dropped till 70. So it's a bit over 30% of reduction in market value for these economies, and that's, I think, quite applicable for all the markets except for China, because here it dropped for about 10%. So the drop in China was not as high as for the rest of the world. Now, if you want to use this for, let's say, the 2007-8 financial crisis, what you need to do is, of course, select a different period. That one was somewhere in September, so let's use August until, let's say, end of 2019. So this is something that you can check. And also, let's make sure that our title is, let's say, financial crisis instead of COVID-19. So if we just change the date and we still keep the same information, we should be able to see how this other event had impact on the markets. So as you can see, the differences between the countries are here much closer. So there's less difference compared to the COVID-19, because this was it didn't really matter how the separate countries managed it, because there was not much that could be done compared to COVID-19. But we can see that the drop was, well, there was some drop from before, but it was probably like 50% on average for these countries. And also the recovery was also slow, but it was more aligned. And at that time, we can see that the worst recovering one, the slowest recovering, was Japan. Then it was France, and then there actually Spain was on the top, if we take a look at this period. So this is basically how you can analyze for any event, and it can be some company event of announcing some new discovery, or it can be something that's not good for the company. So a scandal, for example, if you take a look at Volkswagen or other companies, especially car companies that had some scandals, you can check that. If there is a major discovery in a given sector, or for example, if you want to check the impact of COVID-19 of airline companies, then what you would do is you would select only the airline companies here and then basically do the same. So this would be the ticker of the company. Here you would have the dictionary, so you have some more information when plotting. Or if it's an event that impacts countries, then you would it would be a better choice to go for indexes instead of companies. So make sure that you have the correct data selected initially, and then basically for the rest, you just need to have to make sure that the event falls within these dates, and ideally it would be as early as possible after your start date. Because if I selected a period that's after the COVID-19, then it's not really a good representation. It would be just maybe the recovery part. So just think of these inputs from your side, and then if you have that correct, then of course the outcome would be much better. That would be all related to this tutorial. For the next one, I would like to cover correlation, so how you can do that with Python, and also which companies are more likely to be correlated with one another, and how would that impact your portfolio. So thank you for following, and I'll see you in the next video.